Hmm. Hello. Jeez. Thanks for sharing, Dan. And hello, Anna. I have a feeling there's going to be less attendance this time around. Just because it's a Thursday night, and man, everybody sat through an hour and a half of calculus, and I sat through about, 7 or 8 hours of calculus today. So we'll see how happy I am. Everyone's trading Bitcoin? Oh dang, my keyboard's not in. Time to check on Bitcoin. Oh, Bitcoin's doing all right. Seems good. And hello, Evan. How are you not taking calculus? Is it because you're at Western and they're not a real school? Hi, Cooper. Oh man, already up to 8 people. The robotics club has checked in. Too many math credits. Feels bad, Evan. That's what you get for being a good student. Oops. Well, good student might be a stretch for you, Evan. But at least a capable student. Your brother is doing his best to follow in your footsteps, Evan. Oh, up to 12 at the start time. Alright. Yeah, I have a feeling we're going to be in the 12 to 15 range. That was what I was expecting. Iron Patriots team 41-31. Oh, nice. Alright, I'm just going to jump into the quiz going over piece. I need you to say I'm a great student at the tutoring center ass. That's good. So I'm going to start off with the first quiz that periods I have no idea and periods I have no idea took, because I don't remember who took what, and I have not graded any of them, sorry. I've mostly finished the retakes, but that's about it. Because, like, I got home an hour ago and I just ate. So, yeah, starting with quiz 17. For which values is f of x increasing? That's just where it's positive. So here, here, and here. Whoa, that's so wrong. What was I sketching in that last one? And here. So I just need to get the x values for where that's happening. So I said it was from negative infinity to negative 0.7-ish. Don't freak out if you said 0.8. I think that's also pretty reasonable. And then also from negative 0.5 to about 0.7. And also from 2 on. So increasing is just where is the derivative graph positive? And then it says find the inflection points. So let me clear up my graph here. The inflection points happen at the maxes and mins of the derivative graph because remember, the slope of the derivative graph is our concavity. So when our concavity changes, we have inflection points. So right meow, and right meow. So as far as labeling where those are, negative, I guess I got to call it 0.6. 0.2-ish. And 1.7-ish. And then our next question, the mean value theorem one, we're going from negative 1 to 2. So it's like, hey, where do I have this slightly negative slope? And it happens a bunch. It happens here, it happens here, and it happens here. So if I had to estimate those values, it's like, yeah, negative 0.6 again-ish, but it's like just before that, whatever. 0.3-ish, and 1.6-ish, or 1.7-ish. I don't know. I'm not going to be that picky as long as, like, if you sketched it on the graph and gave points that are reasonably close to there, I'm super happy. That sounds great. Okay, on to our next section. The implicit differentiation one. This one was common to every single quiz because I was too lazy to make 2 of them. So, yeah, I guess I did not dissuade cheating this week and telling your buddies about it. But if you distribute the x squared in, you get 9x squared minus x squared y squared equals 8y squared. You take the derivative of this, you get 18x, and then you got a little bit of product rule here. Minus 2x y squared for the derivative of the first times the second, minus x squared times 2y dy dx. For the first times the derivative of the second, and then for this guy, it's just 16y dy dx. And I need to solve for dy dx, so I move to this crap over here. I got 16y dy dx plus 2x squared y dy dx equals 18 minus, or 18x, whoops, minus 2x y squared. And then I just divided by 16y plus 2x squared y. So I got dy dx equals that stuff. And then you just plug in 1. So you get 18 minus 2. Okay, that's 16. And 16 plus 2, so that's 18, and so it was 8/9. 16 over 18 or 8/9. I accepted. I will accept either of these when I finally get to grading these. And for our last one on this version, our related rates question. Hopefully this is pretty family friendly. I haven't graded these yet, but I'm hoping people did at least alright because we did a ton of cone problems. So v equals 1/3 pi, but I don't want r squared, so I got to figure out what r is. So r over h in this case was 3/4 because this is the diameter, the 6 feet across the top, and the height is 4 feet. And then I found that r is 3/4 h, and now I don't need to write r squared. I can write 3/4 h squared h. Now you just expand the squared, and you get v equals 1/3 pi times 9/16 h cubed. And we're ready to take the derivative. We just go right to that. dv dt equals, this 3 always kills that 1/3. So pi times 9/16 times h squared dh dt. And then the stuff we know is that water is flowing into the tank at a rate of 3 cubic feet per minute. So that dv dt is 3. Sick. And h is 2. The height of the water is 2. The depth, or yeah, whatever. So I multiply by 4 here for 2 squared, and I just need to find dh dt. 36 over 16 is what this is, so I multiply this by 16, 48, and divide by 36 pi. Cool. So this is just 4 over 3 pi, and our units are, in this case, feet per minute. This one's simplified nicer than the other version. Okay, I'm going to head back and see if I've just been going too fast or whatever. I don't know. Let's see how people are doing. Okay, good. Johanna's answering questions in chat. That's normal. Oh yeah, I'm going to go do the other one now. So essentially, I'm only going to do the first to third questions. Why did I say essentially? What does that have to do with anything? So this was the quiz that first and fourth period took, I think. And this is the quiz that the other two classes took. So starting off with 17 on this guy, I'm not going to do 19 again because 19 was exactly the same on both versions. Wow. Alright. Oops, that's the wrong button. Okay, so where's this thing concave down? What I care about is negative slope. So I'm talking about over here. I'm talking about from here to here, and that's it. So I just need to say from negative infinity to negative 0.6 or so. And then from 0.2 to 1.7 or so. So again, just where my derivative graph has negative slope, because the slope of the slope is the concavity. Concavity, if that tilts you, whatever. Alright. Locate and describe the extrema. So what I was wanting on this quiz was for you to say, hey, at negative 0.7, that's a max. because it switches from increasing to decreasing. And then at negative 0.5, that's a min because it goes from decreasing to increasing. Remember, the decreasing and increasing thing is just negative to positive value. It has nothing to do with the slope of the derivative graph, just the value of the derivative graph. So here we switch from increasing to decreasing again, so that's another max. X equals 0.7 or so. And here at 2, we have another one. We go from decreasing to increasing, so that's a minimum. And that's it. So x equals 2 and x equals negative 0.5 were the minimums, and x equals negative 0.7 and x equals 0.7 were the maximums. Okay, now this quiz had the mean value theorem from 0 to 1. So right here to, okay, I have way too much crap on this. Let's erase it. All right, from 0 to 1, so from here to here. So where do I have this slope? And if I had to guess, it would be here-ish. So that's like 0.5-ish. Cool. This one only had 1. So this is kind of the balance of difficulty level. I kind of made this one easier on this quiz, and I made this one a little harder, the B one. Yeah, that was that one. So x equals 0.5 is about where the mean value theorem is guaranteed. Remember to only pick values that are on the interval. If you picked values that are not from 0 to 1, you probably didn't get it right. All right, moving down to 20. Okay, the radius is 4 here. So in this problem, unlike the other problem, our r over h relationship was 4 over 3 instead of 3 over 4. Wow, I'm so original. You get r equals 4/3 h for the radius equation. And we plug this crap into the volume equation. So v equals 1/3 pi r squared, where r is 4/3 h squared h. You expand that out. You get v equals 1/3 pi 16 over 9 h cubed. You're ready for the derivative here. dv dt equals, and once again, I have the 3 kill the 1/3 when I pull it down, pi times 16 over 9 h squared dh dt. And now looking to my problem, what do I know? I got dv dt equals 5, cool. And I also got the water height is 2, just like the other one. So 5 equals pi times 16 over 9 times 4 again for 2 squared equals dh dt. And I just got to solve for dh dt. So in this case, dh dt is 5 times 9 is 45. And the top is 64 pi. So 45 over 64 pi. I don't think that simplifies, because 5, 3, and 3 go into this, and 5, 3, and 3 don't go into this at all. So this was just how you left your answer, and the units were feet per minute. So yeah, hopefully about exactly the same difficulty as the other version. And let's go back and check and see what's up. Will the graphs for 17 be nicer on the test where it isn't a bunch of decimal garbage? No, honestly, it's probably going to be just as much decimal garbage. The difference is, because they're multiple choice, they're going to tell you what the decimal garbage is. Kennedy didn't use fancy wording for his answer in 20. Yeah, I'm actually accepting more than fancy wording, but I could. Facecam, that's not happening. Play some Hearthstone? Oh gosh. Did that show up somewhere? Oh, whatever. I'm too tilted with Hearthstone right now, and I don't have the new any of the new expansion or anything. Alright, so back to it. Where should I go in the review or anything like that? Your browser doesn't support my stream? Time to get Chrome, dude. Okay. So yeah, do people want me to go look at the multiple choice review? I'm not 100% sure where people want me to do. Bye, Eric. Sorry. Anyone pointed me anywhere? Not yet. We're not doing Minecraft. Oh my god. No. Alright, yeah, but which multiple choice, Peyton? I need some direction. Number 11. Hey, that's some direction. Thank you, Anastasia. Go over the MC review. Man, but like which questions? They're not all brutal. The multiple choice is pretty straightforward. Harder 3D related rates. 3D related rates? What does that mean? Like volume shapes? 8 and 11. A hard one, yeah. None of them are hard for me, guys. I need some direction. Yep, that's the one. Alright. 8. How many points of inflection exists for the twice differentiable function? So this is a second derivative graph. That's the key idea. Oh, I'm not in writing mode. My B. So what we're looking for, if we're looking at the second derivative, is places where the concavity changes. Those are inflection points. Since this is a graph of concavity, we need it to switch from positive to negative or from negative to positive. And that only happens twice, at 5 and at 7 here. So that's 2 times, so the answer is D. It's really tempting to say that these are inflection points, but they aren't because it stays concave down. It bounces off 0, but it stays concave down, so it's not actually an inflection point. 11. Okay, so 11's a snazzy problem where I could potentially give you the derivative right away, and all you have to do is do the first derivative test to test whether or not it's a whether or not there are minimums or maximums at those critical points. So what I did real quick is said this is always positive because it's squared. So the only things that can affect my sign are the 2 and the 4. So I know the 3 is kind of garbage, but I'll still test it. For 2, 3, and 4, I plugged in 1, 2.5, 3.5, and 5. I know if I plug in 5 that all of these are positive, and so that's good to go. If I plug in 3.5, this one is actually negative, this one's always positive, and this one is still positive, and so that's negative. That's going down. If I plug in 2.5, let's erase what I got here so I can focus on 2.5. This is negative, this is always positive, and this is still positive, and so this is still negative. I had told you nothing was going to happen at 3. This is why. And then lastly, when I plug in 1, everything, well, okay, so this one is negative, and this one is negative, because 1 minus 2 is negative, but the middle one's still positive. So negative times positive times negative is positive. And so you can see we have a max at 2, and we have a min at 4. And so this says a maximum at 4. That's garbage. A minimum at 3, no, nothing happens there. A max at 2, heck yes, that one. So it's 1 only. Alright, I'm going to duck back to the chat to see if any new problems got added. Okay, lots of votes for 12. 12, 7, and 15. Sounds good. That's my next round. Okay, yeah, 12 is like legitimately one of the hardest questions on here. Like, I check my answer key for the previous year every time because I want to make sure I got it right. These are tricky questions. There's a lot of words. So first we have a continuous function. that's kind of big for this. You have to understand that like what exactly a continuous function gives you to get this question. We have a closed interval, so we know that we have we're going from like A to B, and we have some sort of thing going on in between that's continuous. Our first thing is that it goes through 0. That's ridiculous. We, in no way, shape, or form, have to go through 0. If our axis is down here, like we could stay above and just chill, and that's fine. There exists a number C on the open interval AB such that it's in between the values of A and B. The reason why this one's garbage is there's no guarantee that A and B are different. Like, it didn't say that anywhere. Like, okay, so in this graph they look different. But say I had some other graph, and here's A, and I just go and chill, and here's B. Yeah, it turns out I never was between those two values. It also implies that B is higher than A, so I could also just go down and it disproves it, because B is lower than A, so this is not possible because of that. There exists a number C on the interval such that f of C is greater than or equal to f of x for all x on A to B. That means that there has to be an absolute max on the interval. This is the one that's like, heck yes, there needs to be an absolute max on our interval. For every closed interval, there is an absolute maximum and an absolute minimum, as long as it's continuous. So this is just saying greater than or equal to. So for our flat line, all of the points would be f of C. But for this one, that'd probably be our high point there. And so this is totally, heck yes, that's good. But I want to finish going through these to talk about like why they're crap. So there exists a point where the derivative equals 0. That means that there's a min or a max on the interval. And we definitely had it in this picture, but in the flat picture, no. And in the straight line going down picture, no. So this one's ridiculous. We don't need that. And our last one, this is the like hardest one to differentiate why it's not okay. Because this is the mean value theorem, that the instantaneous slope equals the average slope on the interval. And the reason why this doesn't work is because for us to do the mean value theorem, the function needs to be differentiable. If it's not differentiable, we can't do the mean value theorem, which is why we can't do the mean value theorem across cusps. If you remember on our last quiz, we had kind of this dealio going on, and I accepted answers that said, hey, this is a cusp, we can't do the mean value theorem. And so that's why that one's no good. There's no guarantee. It just says it's continuous. It doesn't say it's differentiable. So yeah, that one's garbage too. And so only C was any good there. Alright, where else was I going next? I talked about that a lot. 15, 7. Alright. Alright, we'll go to 7 and then go to 15. Okay, so I need the problem here. How do I do this? Like that, I think. Alright, so our function is x of t equals t cubed minus 7t squared plus 8t plus 5. And it's saying, what is the position of the particle when it is farthest to the left? In order to pull off farthest to the left, we want the most negative value. And so to do that, it really helps if we know what the answer to 6 is, because it kind of informs us for how to answer 7. So we find the velocity equation for this, the derivative of x. You could say x prime of t. That's perfectly legit. That's 3t squared minus 14t plus 8. You kind of get some hints on how to factor this because they like freaking tell you the values, and so that's like how I factored it when I worked on this. So I know it's like 3t minus 2 to get 2/3 there, and t minus 4. Cool, yeah, 2 and 4 multiply to 8, 2t, 12t, sick. Then we test on either side of these. So 2/3 and 4 are my two critical points. 1, 0, and 5 are on either side of them. And if I plug 5 in, both of these are positive, so it's positive. If I plug 1 in, this stays positive, this goes negative, so that's negative. And if I plug 0 in, it's negative times negative, so that's positive. So on which intervals were we increasing? It was these ones. And now that we have this picture, we can see we are increasing from 0 to 2/3. Then we're decreasing from 2/3 to 4. So when we're decreasing is when we're going to the left. And since we spend all like 3 1/3 x's going to the left, or t's rather, going to the left, our farthest left point is going to be at 4. And so all I do is plug 4 into the original equation. So I get 64 for t cubed, 4 cubed, minus 7 times 16 for 7 times t squared, plus 8 times 4 plus 5, and I just figure out what this is. 7 times 16 is 80 plus 32, so 112. This is 32 and 5. So 64 minus 112 is negative 48. Plus 32 is negative 16. Plus 5 is negative 11. And booyah, we found the position of the particle when it's farthest to the left. All right, now to head to 15. Oh yeah, I've explained 15 a lot today. Here's my favorite explanation for 15. If you know what the graph of a sine function looks like, you know it looks something like this. And what we're looking to do is find a maximum value. So since this is the derivative, I want where this thing switches from increasing to decreasing, because increasing to decreasing is a maximum. So I want where it goes from positive to negative. And that's right here. And if you remember your unit circle or just parent functions for sine, you know that this happens at pi. And so what we're looking for is where the inside of our parentheses equals pi, because that's the point where we switch from increasing to decreasing. So I want where x cubed equals pi. And so I just cubed root both sides, and x equals the cubed root of pi. And that one's a 1.465. These ones are like way too big, D and E. Zero's obviously garbage, and 1.162 does not get big fast enough. So this is technically pretty doable without a calculator, but it helps to have a calculator, and I assume this question, when it was created, was meant to have a calculator allowed for it. Yeah, I like that question. It's pretty cool. Also, this, if you were to actually figure out the original function to this, you would need to be in Calc BC, and probably later in the year than the current kids are in there, because this is pretty horrible to do. Can you do section 4 stuff, specifically limits at 0? I can. Wait, did I get something wrong for 6 and 7? So wait, for 6, why do we look at where the derivative is positive and negative? No, that's not the position increasing and decreasing, because I'm looking at where the derivative is positive and negative. So that's moving right and moving left. Positive is moving right, negative is moving left. And so it is position increasing and decreasing, but it's really talking about like the velocity of the particle in which direction. Number 7, I got negative 16, but answered negative 14. Did I do that? I don't think I got either of those, did I? I think I answered negative 11, because that's what I got, because I think that's right. What's the equation? Crap. So it's 64 minus 7 times 16 plus 32 plus 5. 64 minus 112 plus 32 plus 5. So 96 minus 112 is negative 16 plus 5 is negative 11. Yeah, if I didn't circle negative 11, I'm sorry, but the answer to 7 is B, negative 11. Oh yeah, that's the right answer, negative 11. I got negative 16, but then I added 5. So I just didn't like show my work for the last edition. Can I explain why 12 was C again? Dear people, when you say WTF, that gets censored. And I'm too lazy to actually check the chat and allow it. And yes, Anastasia, that's exactly it. I didn't show that step, but I did the second time I did it. So hopefully that helped. Alright, so where am I supposed to go now? Explain why 12 was C again? Dang, I wish I had kept all my notes. So the reason why C is cool is easy for me to talk about. So the reason why C is cool is this just says there is a maximum on the interval. And what we know about absolute maxima and minima is that as long as the function is continuous on the interval, there is a maximum value. That's the whole point of absolute extrema, is that as long as we're continuous, we can pick out which of those, which is what. So like, for example, if I just connect this with some random function, notice there is an absolute maximum here. The only way I wouldn't have an absolute maximum is if there's some sort of like janky, maybe like some asymptotic garbage, or perhaps I have a high spot with a hole on it, and then I go like that, so our absolute maximum here wouldn't exist. But this is disallowed. We're not allowed to have the hole up here if it's continuous. And so that one's A-okay. Because it's continuous, this has to be true. Apparently, what the heck is also banned, but I'll show that. Which question are you doing? I'm lost. Well, sorry. Could you explain on 7 why you use 4 in the original equation? Yeah. So I'll go to 7, and I'll head to wait, Tom. I literally just did 6. I'm confused. So the reason I chose 4 for 7 is based on the answer to 6. So the answer to 6 was this, and I did that work a little bit ago. Essentially what that's saying is that we are increasing from 0 to 2/3. So let me try to sketch this garbage here. So say we started at 0, 0 just for giggles, because it didn't tell us at all where we started. Oh no, it did. It told us we start at 5. Never mind. We're going up a little bit till 2/3. Then we're going down until 4. And then we're going up again for the end. So this is an approximate sketch, very approximate. It's probably completely garbage. But the point is, it shows that because we are decreasing from 2/3 here to 4, 4 is indeed our farthest to the left spot on the interval. Because it's where we stop decreasing and switch to increasing again. After 4, we switch to increasing, which means we're getting less left. Remember, on my graph here, stuff this way is right, and stuff this way is left. And so if I wanted my most right spot, I'd probably want the end of the interval 10 here, because I bet this t cubed dominates, and this thing gets tall here at 10. In fact, I know it does by looking at the numbers. But yeah, farthest left is at the end when we stop decreasing, because where we switch from decreasing to increasing is a relative minimum, and that is our smallest term for that one. So this is why I plugged in 4 and why I got negative 11 for 7. You did not explain 6 for speed, only for velocity, which is not what the problem was talking about. Oh, am I a deadbeat? I am a complete deadbeat. Thank you. Yeah, no wonder Johanna was flaming me about that. Well, we'll actually answer this question correctly. So all my explanation was apparently for 7. For 6, I'm a deadbeat. All right, so let's go here and look at this. So velocity. Here's our equation. But what we're looking for is where the speed of the particle is increasing. This means that the velocity and the acceleration match. When speed is increasing, it means velocity sign equals acceleration sign. And where they have different sign, that is where our speed is decreasing. The reason why this is true is because when we're diving down in the negative direction like this, our speed is increasing. We have negative slope and we are negative concave down, so our speed is increasing here. And we need those to match up. Same way as if I dove up this way, my speed is increasing. I'm going up at a faster and faster rate. That is speed increasing. So I need to make sure my velocity matches my acceleration. So I not only need to figure out the velocity intervals, which I have defined as this answer, which isn't the answer to the problem, but is the answer to the velocity intervals. So for velocity, I'm going from 0 to 2/3, I'm going up. From 2/3 to 4, I'm going down. And from 4 on, I'm going up. But I need to figure out the acceleration, so I look at 6t minus 14. That's the derivative of 3t squared minus 14t plus 8. So this is our acceleration equation. I can see that there's only one inflection point, or pip, in our second derivative. It happens when 6t equals 14, so at t equals 14/6, which is 7/3, which is why I should have noticed that there were 7/3 in here, but didn't. Whoops. And now if we test on either side of this, if I plug in 1 and 5. Well, at 1, this is negative, so we're concave down. And at 5, this is positive, so we're concave up. And so remember, I need these to match. So I am concave up from 7/3, which is 2 and 1/3, on. And the only spot my velocity matches that is from 4 on. So for those to match, 4 to 10 is still a good interval where the up and positive velocity happen. And then my concave down part here, my negative velocity section, matches up with my negative velocity here on this interval from 2/3 to 4. But we don't make it all the way to 4. We only make it to 2 and 1/3 with negative velocity. So I'm actually talking about the interval from 2/3 to 7/3 here. And so that's why the answer needs to be this guy. That accounts for the entire 4 to 10 for my up and velocity positive. And for the interval from 2/3, where our velocity switches to negative, to 7/3 while our acceleration is negative. So again, these need to match up for us to be our speed to be increasing. And so I'm sorry for being errant and answering that question incorrectly previously. If you're like, wow, Mr. Kennedy, your work is a steaming pile of garbage, there's another way to visualize this. We can say velocity is this and acceleration is this, and we're going from 0 to 10 here. And our velocity is, let's see, where's our velocity graph? We're positive from 0 to 2/3, so for our first little bit, we're positive. And then from 2/3 to 4, we're negative, and from 4 on, we switch back to positive. And if I look at my acceleration is negative from 0 to 7/3. So like maybe there. And positive from that point on. So as you can see from this, our acceleration matches our velocity on this interval, which is 4 to 10, and on this interval, which is 2/3 to 7/3. And this is probably the clearest representation of that. And once again, sorry for getting that wrong. I bet that's wrong in my solutions I posted, rip. Is there going to be a question like 6 on the test? There very much could be. Yeah. So, yeah. I mean, basically anything's fair game. I don't know. Any other questions on the review? I would agree that 6 and 7 are 2 of the hardest questions on the review, so those were good ones to direct the live stream towards. Oh dang, my OBS is dropping. Oh, it is right in the solutions? Well, then I'm an idiot. Why is my OBS dropping frames? My CPU's not busted. Do it again, but better? I'm confused. What? I thought my last explanation made some sense. Well, is that what people want me to do? Is there nowhere else people want me to go? Andrew, I might just give you a quick explanation as to how this works. The quick explanation is my thing at the end. For 0 to 10, I need my velocity sign to match my acceleration sign. And I said my velocity was positive from 0 to 2/3. And then again from 4 onwards. And I said my velocity was negative from the 2/3 to 4, which is why I use 4 as my spot where the position was farthest to the left. And then for acceleration, I said 7/3 was my inflection point. And at 7/3, before 7/3, we were concave down, which means that our acceleration was negative. And after 7/3, our acceleration was positive. And what we need is for the acceleration and velocity to have the same sign, because negative with concave down is increasing speed. We're like parabolically going downwards, which means our speed is getting faster at a faster and faster rate. It's basically we're accelerating in the negative direction. And that's what's happening on this interval. We are concave down and our velocity is negative, which means we're getting faster and faster negative. And then what happens at the end, where both our velocity and our acceleration are positive from 4 to 10, is we're concave up and our slope is increasing, which is also a speed that is increasing at a faster and faster rate, basically accelerating in the positive direction. If these don't match, like if I went back down to my concave down, or sorry, my negative area, if I'm decreasing but I'm concave up like this, my speed is not increasing. The rate at which my speed is increasing isn't increasing. So when these don't match, my velocity is still negative, but it's getting less and less negative. And that is what makes this not where the speed of the particle is increasing. It means our velocity is still negative, but our speed is not increasing. And so we need those to match for speed to be increasing. Speed is decreasing when we're like back approaching the axis. This is decreasing speed as we head towards 0, and also decreasing as we turn around and go back this way. And so we're looking for things where we're increasing at an increasing rate. Rip the Bitcoin. Oh no, my stream's back to good health. Bitcoin crashed again? Yeah, Bitcoin's a wild ride. Bitcoin is hilarious. Yeah, I have $400 of Bitcoin, so I'm just along for the ride. 400 is like not much of my investing portfolio. I just think it's funny. Any other questions in the review that are like pretty awesome that we should look? Also, I bought Bitcoin at 9K, so unless it drops to like, I don't even care if I lose all my money. Yeah, I don't care at all. Anything else in the review? I know the Bitcoin talk is very fun. Do a practice free response question. Can you do the 4 zeros one? Do the entire review again until we run out of time. Oh, Lord. Wait, didn't I say I was going to do an optimization problem? I think so. So I'd be happy to do another one of those questions. I think if I pull up, I forget which one exactly. No, I put this here. So I handed this worksheet out, I forget when, I think it was the day before my sub day. It was called like AP question battle on the front. This is a homework assignment. There were only 7 questions on it because the last one was garbage. But on the back of that, it has like all the things you do with the derivative. This might be useful study material for the tests, like the first half of this unit in a nutshell. It says like use the original function for the y value, for absolute extrema. Use the first derivative for all this crap, and I talked about a bunch of different ways I could ask for the first derivative. So like we messed with the find the tangent line equation, or slope of the tangent, and so on. And the second derivative, it talks about the ways to ask for that. This, vocabulary-wise, would be really useful to review. I did make this with the intent of it being looked at, and then I put it on the back of a homework that was a little too early for when it might have been useful. It may have been useful to just have this embedded in our notes. So yeah, maybe I'll think about that for next year. That would probably be a better choice. But know that this exists, and this is quite useful as far as resources go. But yeah, I was going to open up something that had the free response question on it. Which one was that? This one. Yeah, I mean, the picture's a lot nicer with color. Look at that. That's out of your book. Anyways, going down here, I just need to build a new function that doesn't suck for this. That's always fun to do. Actually, you know what? Who cares if it sucks? What do I remember from the book? Because I often look to the book to make these questions. Let's do x squared over x minus 1. That seems like a good function. And just go through the free response process for this guy. So for the first derivative, I got to do the quotient rule. So the derivative is bottom d top minus top d bottom, which is just 1, over the bottom squared. If I distribute the 2x in, I get 2x squared minus 2x minus x squared on top, which I can just simplify now to x squared minus 2x over x minus 1 squared. And that's my derivative. So if I factor the top, I can find my critical points. My critical points happen at if I factor the top, I get x times x minus 2, so they happen at x equals 0 and x equals 2. So it'd be 0, comma 0, because if I plug 0 in, it's 0 over 0 minus 1. And if I plug 2 in, it's 4. So, whoops. 2, comma 4 is another critical point. I get 4 because I get 4 on top and 2 minus 1, which is 1 on the bottom. Now I got to figure out which one of these is a max, so I test values in between, 1, 3, and -1. The bottom is squared, so it's always positive, so I just ignore it, and I just plug things into the top. If I plug -1 into the top, I get negative times negative, that's positive. If I plug 1 in, I get positive times negative, that's negative. And if I plug 3 in, I get positive times positive, that's positive. So both of these are extrema. This guy is a maximum, this guy is a minimum. So 0, 0 is my relative max. 2, 4 is my relative min. This is the kind of problem that tilts people because the min is a higher y value than the max, but part of that's because we have this very clear asymptote at x equals 1 that sends things awry. So if I take a second derivative, I get bottom d top 2x minus 2 minus top. Oh man, I'm running out of room. Time to kill all this garbage. Minus top d bottom all over the bottom squared. And man, when that bottom is different, things get a lot hairier. Now there is some simplification you can do in this case. We have x minus 1s in every term, so I just killed one of each of them and lowered this to a power of 3 initially, because that makes a lot of the simplifying a heck of a lot easier. So what I get is 2x squared minus 2x is negative 4x plus 2. And here I get negative 2x squared for 2 times negative times x squared. And 2 times negative 2x is plus 4x. And I'm like, wow, rad. So much stuff cancels out. I just get 2 over x minus 1 cubed. So at 1, we have our inflection value. It's not an inflection point. If I was going to say inflection points, I'd just say none. But like 1's the important spot where our concavity changes. If I test on either side of 1, in the second derivative, I test 0 and 2 in there. And when I plug 2 in, the bottom is positive. And since the top is always positive, I just get going up. So concave up over here. And when I plug 0 in, the bottom is negative. Negative 1 cubed is negative. And so that's concave down. So my concave down interval is from negative infinity to 1. And my concave up interval is from 1 to infinity. And I guess I never got my increasing and decreasing. Alright, so it's increasing from negative infinity to 0 and from 4 to infinity. And it's decreasing in between. And there's one of our free response problems with maybe some cool tricks like the canceling out the x minus 1 things when you do the quotient rule and some factoring. Yeah. Hopefully that answered some people's questions on how to go through that process. How's the Thursday crowd? Bigger than expected. Wow, alright. When you're backstage during the play, oh, feels bad, man. Can you do an optimization problem? Let's go for it. Alright. So, where did I put my optimization problems? Here. So I got operating a truck as a good one. I think this one is decent. And the cattle company. A lot of these are like the warm-up today, these sort of questions. So maybe our first one is kind of the most interesting of the questions. So yeah, I think I'll go for this one. So we have an operating cost of a truck. It costs this many cents per mile. So the more miles you drive on the truck, the more it costs. Or psych, the faster you drive in your vehicle, because X is miles per hour, the more it costs. So I assume that's the gas mileage or something. If a driver earns $6 per hour, what is the most... That's awful, holy smokes. What is the most economical speed to operate the truck on a 400-mile turnpike? Due to construction, the truck can only travel between 35 and 60 miles per hour. So immediately we go, this isn't just an optimization problem. This is a closed interval from 35 to 60. This is a absolute extrema problem. So I'm definitely going to be testing 35 and 60, and I'm going to be trying to see if my critical point is somewhere in between. So we're trying to go for like economical, so I'm going to call it a profit equation. Is that a terrible choice? Yeah, it's more of a cost equation. I'm going to call it C. So our costs of operating the truck, we definitely have the cents per mile at our speed. So our cost per mile is 12 plus x over 6. But if we so if we think about it, this is cents per mile. So this is dollars per time. Our other thing here is in miles per hour. So this is miles per time. And our guy earns $6 per hour. So it's also going to charge us $6 per... X is not miles per hour. X is not hours. X is miles per hour. So this question is very confusing to set up, as many related rates questions are. And so we have to go through some creativity to set this up. So cents per mile, is what we want to plug in miles? No, what we want to plug in is miles per hour. So we need to find a way to come up with what hours are, because this was money per mile. And dang it, I really should have prepared for these. I just had absolutely no time, so I'm sitting here derping over this. This is a hard question. Yeah, I'm an idiot. Don't worry about me. So for our truck driver money, we know that the turnpike is 400 miles long, so how long he's working is 400 divided by our speed. The reason why this works is because the number of miles divided by the miles per hour gives us the number of hours. Or not really that. Oh my gosh. I'm really tired. I taught way too much today. I'm burning out. Let's see how many people are flaming me right now as I struggle my way through this. Does 55 miles per hour for work... Oh, Lord. If Kennedy can solve the problem, we shouldn't be expected to either. Yeah, so since I was a complete disaster on that question, let's move on to another one so I can raise my confidence. I remember that question being hard, and I was like, yeah, it's the most interesting, and it is, but I feel stupid right now. Let's go to a more family-friendly one. This is like our warm-up today. Our commercial cow company allows 20 steer per acre. On average, a steer weighs... Oh, man. On average, a steer weighs 2,000 pounds at the market. Estimates by the Department of Agriculture indicate that the average weight per steer will be reduced by 50 pounds for each additional steer added per acre of grazing land. So like at the start... We have 2,000 pounds of meat, and we have 20 pieces of meat per acre. So this is our amount per acre, but obviously we're going to change this. Every time we add a steer, the average steer loses 50 pounds, because ostensibly they're getting less food. So my actual revenue equation for the cattle company field is going to be 2,000 pounds minus 50 every single time I add a steer. And how many steer I have is 20 plus X here. And so this is like super similar to our warm-up today. If I solve my revenue equation here, I get, or FOIL basically, I get 40,000 minus 100x, and by 100 I mean 1000x, because that's what 50 times 20 is, plus 2000x minus 50x squared. I just take the derivative. Well, actually, I'll combine like terms and not be a slacker like I was in class. 40,000 plus 1000x minus 50x squared. Now I'll take the derivative and set it equal to 0. So 0 equals 1000 minus 100x. I add 100x to the other side, and I get 100x equals 1000. So x equals 10. So, how many steers per acre should be allowed? Notice x equals 10 is not our answer. If I box that up, I'd be like, 10 steer per acre. That would be super wrong, because that would, if x was negative 10, that would be true. So I actually need to do 20 plus 10 to get that there should be 30 steer per acre to actually successfully solve this question. And yes, you could guess and check your way to that, but remember, when you have 2 or 3 minutes per question on the quiz, notice how this took me like 2 or 3 minutes? Yeah, you want to be like doing the most efficient way, and this is definitely, the calculus way is the most efficient way to do this. Seriously. I vote we just don't take the test. Oh, come on, folks. I'm not going to put that stupid problem on there, I promise. I know, I wrote the test. That question ain't going to be on there. And if we don't take the tests, we aren't prepared for it. Okay, while we're all trolling in the chat here, you should just hand us a BC test. No, that's such a waste of class time. I already have a lack of class time. So for optimization problems, 80% of question is just setting... Yeah, 80% of the question is just setting up the equation. Yeah, that's true. The notable examples were... If I could show them, do I have that? So the notable counterexamples to that is maybe what I'm trying to say, are a question like... Dang it, I already have it open. Like this one off of last night's homework, 29 here, because setting this up was actually really easy. It was solving it that added the extra steps of complexity, because the area equation of this was pretty simple. It's just, this is x, this is x, this is y, 2xy, and they tell us why. But the hard part in this one, which is different than most optimization problems, was doing the chain rule and the product rule for the derivative, factoring out stuff, and getting the answer. Like, definitely setting this up was, in my opinion, easy compared to like 54, where setting it up was hard. So like hard setup and easy math. And another one like 25 is pretty easy to set up, and hard math. So if you notice, we don't really have a lot where it's hard to set up and there's hard math. It's kind of, there's a balance of those. I would say 41 is pretty realistic as far as a question I could put on the test, because everything was kind of easy, although I would give you the area of an equilateral triangle is √3/4x squared if I gave you that. I don't expect you to know that. But that level of complexity is pretty typical. As far as related rates problems, you can bet there's a Pythagorean theorem one on there. I can guarantee that. Pythagorean theorem's reasonably likely for optimization problems also, just because it's so family friendly and, you know, actually makes you do some math usually. Man, I go over all that explanation and we just get ripped grammar. Alright, we're starting to bleed people. And I'm really burning out. I'm sorry I like flamed out on that one question there. Folks, this is the hardest question of the year. Who was saying that? Gabe was saying that. For some reason his last name is losing me. Is not there with me. But yeah, he was talking to me. He was like, oh, have the kids gotten to the hard test this year? And I was like, wait, which one? And he was like, oh, the chapter 3 one. So this really is one of the trickiest parts of the year because we're just doing so much application of derivatives. Like, hopefully those derivative skills are like fresh in the bank and really strong because all you're really doing is applying those things in a bunch of ways. Yeah, sorry again for a little bit of the loopiness. This is definitely not my highest quality live stream. I'm a little burnt out. Hopefully I'm just going to watch some TV and pass out. I hope you guys do the same. Does that mean it gets easier from here? Next unit is definitely easier. The next unit is definitely, unless you're like awful at logarithms, it's pretty easy. Do you have any practice of the hard setup optimization problems? Andrew, I can post that worksheet, including the answers to that worksheet that I did the cattle problem from. I do have that available. Otherwise, I think on my website, I should have, like, CUDA has those worksheets where they have the answers, and I think I saw somebody. You can make it, no. So I think those have answers available to them, for them. So hopefully that helps out with Facecam. Yeah, so folks, part of the reason why the live stream's Thursday is because I am literally booked through the weekend, so sorry, your quizzes probably won't get graded until, I would guess, Tuesday of next week. Maybe I can get some done tomorrow during my 2 preps, but that depends on how many of my preps get invaded by you guys. So we'll see how that goes. To anybody curious, the test is cumulative, but when you think about cumulative, you think way worse things than what this actually is. If you look at our last chapter, literally everything in our last chapter is stuff that we have done ad nauseum this chapter. Chain rule, product rule, quotient rule, derivatives, like all of that crap is just stuff we already know. Have fun this weekend. Yeah, I'm just hoping not to die, honestly, or get burnt out. Get turned this weekend. Whoop whoop. Oh Lord. All right. Yeah. Have a good night, guys. Hopefully you don't have any more homework. Am I going on a date? I have a girlfriend, dummy. Of course I'm going on a date. How's the extra credit on the test? Non-existent. I can tell you that. But the point is, when you apply a curve-ish thing on the test, extra credit doesn't have any impact. Are the weird limit problems? Oh! Yeah, okay. Dang it, I was cooling down, and then I was like, somebody asked me about the limit problem. Yeah, I'll do a limit problem real quick. Give me extra credit? No. Oh, can I just trash this? There we go. So, I mean, as hard as the limit question is going to be, and this is like a really indicative problem on the AP tests, they love doing these sort of questions. That's not the right word there. I'm really burnt out. This is on one of the AP mock tests, like this exact question, essentially. Not one of the ones I'm going to give this year, but one I've given in the past. That's really dumb if I do that. They'll either give you limit at infinity of this, and you have to go, oh, I'm looking at the biggest values. It's going to be a fifth. Or they're going to give you limit as x approaches 0, and I realize I might have gone off the page there. My bad. This is the problem I'm looking at, and if you look at this, you'll see that the limit as we go to infinity of this thing is 1/5. If I take the limit as I go to 0, I look at the smallest power term, so I'm looking at negative x cubed over negative 3x cubed. That's 1/3. And so really they give you these questions to like, can you differentiate between looking at the biggest powers or looking at the smallest powers? Our quiz section 4 kind of prepares you for the hardest questions they could possibly throw at you, but most of their questions, and the questions I am likely to give you, are of this variety, or of the variety where it's like x squared minus 4 over x minus 2 times x plus 3, some garbage like this. And you have to read that the x minus 2's cancel and figure out the limit from there. Figure out that it's x plus 2 over x plus 3 if you cancel out the whole. And then evaluate the limit at these. Like, those are a majority of the limit questions. But absolutely on the free response, there are some that are as janky or even jankier than my quiz section 4 limit questions. So this is most of them, but the challenge questions are as hard as the ones I give on quiz section 4. And yeah, that's essentially the hardest limits. Why are we insulting Kennedy? Did I miss that? Can you fix the answer key for the review? Yeah, probably. Oh. So Tribble was making fun of me. Yeah, yeah, like Tribble can even talk, are you kidding? Alright. Later.